Welcome all to PRISCI Educational Academy. Today we are going to know about the Poisson distribution. The definition of Poisson distribution is probability of x is equal to x, which is equal to e power minus lambda power x divided by x factorial, where x is equal to 0, 1, 2, 3, etc. up to infinity. Let us find the mean. So mean value is equal to expectational of x, which is equal to summation x into p of x. Which is equal to summation x is equal to 0 to infinity x into p of x is, from the definition we can write e power minus lambda power x divided by x factorial, which is summation x is equal to 0 to infinity x e power minus lambda power x divided by the x factorial can be written as x into x minus 1 factorial, which is equal to e power minus lambda summation x equal to 0 to infinity lambda power x divided by x minus 1 factorial, because the numerator as well as the denominator is having x, so cancelled, which is equal to e power minus lambda summation x equal to 1 to infinity lambda power x divided by x minus 1 factorial, because if you are taking x is equal to 0 minus 1 factorial is not possible. That's why we are taking from x equal to 1 to infinity. Now you have to expand it, e power minus lambda into, for x you have to apply 1 to infinity lambda power 1 divided by 1 minus 1 factorial plus lambda power 2 divided by 2 minus 1 factorial plus lambda power 3 divided by 3 minus 1 factorial plus etc., which is equal to e power minus lambda into lambda by 0 factorial plus lambda square by 1 factorial plus lambda cube by 2 factorial plus etc., which is equal to lambda is common in each term, so taking common element e power minus lambda into 1 plus lambda by 1 factorial plus lambda square by 2 factorial plus etc. 0 factorial value is 1. So you know the formula, e power x is equal to 1 plus x square by 2 factorial plus x cube by 3 factorial. So 1 plus lambda by 1 factorial plus lambda square by 2 factorial plus lambda cube by 3 factorial can be written as e power lambda. So lambda into e power minus lambda into e power plus lambda. So bases are equal, e power minus lambda plus lambda. So e power minus lambda plus lambda can be written as e power 0 is 1. So 1 into lambda is lambda. So mean of Poisson distribution is lambda. Next one, e of x square. So e of x square is equal to summation x square p of x, which is equal to, I am subtracting one x and adding another x. X I am subtracting as well as adding, because to get easy calculations, which is equal to summation x square minus x plus x into probability of x, which is equal to summation x square minus x into p of x plus summation x into p of x. Summation x equal to 0 to infinity x into x minus 1 probability of x plus summation x equal to 0 to infinity x into p of x. So we have summation x equal to 0 to infinity x into p of x is, already we got the result, that is a mean value of Poisson distribution. The mean value of Poisson distribution is lambda. So therefore, The denominator x factorial can be written as, already we studied, x into x minus 1 factorial. So therefore, summation x equal to 0 to infinity x into x minus 1 e power minus lambda lambda power x divided by x into x minus 1 factorial plus lambda. X factorial can be written as x into x minus 1 factorial. X minus 1 factorial can be written as x minus 1 into x minus 2 factorial. So therefore, summation x into x minus 1 e power minus lambda lambda power x divided by x into x minus 1 into x minus 2 factorial plus lambda. Here, numerator is also having x into x minus 1. Denominator is also having x into x minus 1. Both you can cancel it. So summation x equal to 2 to infinity, not 0 to infinity. Because 0 if we are taking, we will got in the denominator 0 minus 2 factorial. So it's not possible. So therefore, summation x equal to 2 to infinity e power minus lambda lambda power x divided by x minus 2 factorial plus lambda. Now we have to expand it. For x you have to apply 2 to infinity. So e power minus lambda into lambda square divided by 0 factorial plus lambda cube divided by 1 factorial plus lambda power 4 divided by 2 factorial plus lambda power 5 divided by 3 factorial plus etc. plus lambda. So e power minus lambda, lambda square is common in each term. So you have to take as a common element e power minus lambda into lambda square into 1 plus lambda by 1 factorial plus lambda square by 2 factorial plus lambda cube by 3 factorial plus etc. plus lambda. So e power minus lambda lambda square into e power lambda, because already as I told you, 1 plus lambda by 1 factorial plus lambda square by 2 factorial plus lambda cube by 3 factorial can be written as e power lambda. So e power minus lambda into lambda square into e power plus lambda plus lambda. E power minus lambda, e power plus lambda will be e power 0. So 1. So e of x square is equal to lambda square plus lambda. Variance is e of expectational of x square minus expectational of x whole square. So expectational of x square is lambda square plus lambda. Expectational of x is lambda. So lambda square plus lambda minus lambda whole square. So lambda square plus lambda minus lambda square minus lambda square cancelled. So answer is lambda. So in Poisson distribution, mean is also lambda, variance is also lambda. So thank you all.